We're particularly privileged here in the college because we have Professor Newsome here for 4 months on a sabbatical, and so it's great to have Bill and his wife indeed around for this time. So Bill Newsome is Professor of Neurobiology in the University of Stanford, and also has been running a very successful research lab there now for many years. His research focuses on the neuronal mechanisms underlying vision, visual perception, also on visually based decision making and those kind of related issues in the neurosciences. And so his own research background is extremely relevant to his topic for this morning, brain, mind, and free will. Did my neurons make me do it? So over to you, Bill. Thank you very much.
Okay, so you should view this talk and the ensuing discussion as just an extension of Peter Clark's talk and ensuing discussion. Peter laid down a number of themes and gave you some really nice general introduction, both from the scientific point of view and better than I could do from the philosophical point of view. And I was sitting in the back row all during the discussion just biting my tongue, because almost every great question you guys asked, I wanted to say something about it, but I knew I had my turn coming, so I just sat and tried to stay quiet. But I'm sure that some of the same themes will come up again, and also I probably will change some of my remarks a little bit as we go along to sort of address perhaps some of the issues that were raised. The first thing that I want to do is just tell you a little bit about myself and sort of where I'm coming from in this whole religion-science dialogue at a global level. And when I talk with people about religion and science issues, the issues that come up as seeming points of conflict generally fall into two categories. One is religions and the findings of science. Haven't scientific discoveries disproved, religious points of view or disproved specific things that religious people believe in? And to me, the answer to that is a clear no. To me, the Big Bang, all the things you heard about on Monday about anthropic principle, the things you heard from John Bryant yesterday about evolution, we don't have to choose between our religious faith or any of these three things. I think these scientific findings are actually remarkably consistent with the key spiritual insights of the Christian faith, which is the one I know best. So I don't think that the findings of science present any serious tension for religious faith. Sometimes there is tension in terms of habits of mind about the assumptions that science makes. People in my lab sometimes are quite surprised when they find out that I'm a religious person, because I'm known as sort of very demanding about standards of proof that I want before I'll admit something scientifically into the canon of what I believe to be true about the world, or believe to be true about the nervous system in particular, or the visual system even more particular, which is what we study in the lab. And then they find out I'm religious, and they say, whoa, 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 where did that come from? I mean, this is so different from the way you normally think. And I admit that there are tensions, because in science we are determined, we try to base our thinking and what we accept as true as much as possible on empirical evidence that's been wrapped in some kind of theory. And that can't always be done in the arena of religious faith. So there are differences. I mean, there are more similarities, of course, between science and religion than is sometimes acknowledged. But there are differences. Science tends to be experiment-based, it tends to be very precise, and it tends to be objective in the following sense, that it can be transferred across communities. So if we do an experiment and do it well in my laboratory, and if we write it up in a paper with all of our methods, that paper can go anywhere in the world, and those findings can be reproduced objectively by anyone who has the proper equipment and proper sort of theoretical and technical orientation. They can reproduce that quite objectively anywhere in the world. Doesn't matter. It's transportable. Whereas in religion, it's not as transportable from person to person, right? Religion tends to be more holistic. We tend to have a greater reliance on intuition and gut feelings about what you believe to be true of the world, and it requires commitment to certain propositions and certain ways of acting in the absence of what we would consider to be scientific proof. And that's what my students and postdocs sometimes mean when they say to me, well, why do you even go there? Why do you even go into that world? Why not just stick with science? And I literally get asked that question. And my answer to that question is that the most important questions of life are not actually susceptible to the solution by the scientific method. So I think science is applicable to a part of our experience, but it's a rather restricted part of our experience, and it tends to be practiced by professionals. And in contrast, the most important questions that each of us generally have to answer or want to answer about our lives, you can't go in a laboratory and give an answer to those questions. So here's an example of a question that is important and that is hard to get an answer to in a laboratory. Is it better to live or to die? And almost everyone in this room probably knows someone for whom this has been a serious issue at some point in their lives. Is it better to live or to die? And I submit to you, there's no program of scientific investigation that will ever get an answer to a question like that. Here's another one. Should I pursue a professional opportunity elsewhere in the country? Should I uproot my family and move everyone, all of whom have their own independent lives, their own sets of friends, their own social milieus, the things that they're doing? And again, you have one shot at this decision, and you can't go back and redo it over and over again, see which one is actually the best, and say, okay, I'll take that one, right? You have one shot at this. You can't do controlled experiments. Here's another one that's highly important and influential. Should I marry this particular person? I mean, this really is an act of faith. If you wait around for scientific proof that this person is the one you're meant to marry, you'll be waiting forever. You will never get married, right? And what I would argue is that this is just the human condition. It's life, and all of our most consequential decisions, the things that matter the most in our lives, have little or nothing to do with science. And that's true for everyone. It's not just for me. It's true for me. It's true for all of you. It's true for my scientific colleagues. And this is the normal mode of decision making. And I would say that for everyone, for all of us, atheists, theists, Americans, Indians, whatever, for all of us, the real question is there an ultimate source of meaning and value in the universe? And if so, what is it? And to me, that's a quintessentially religious question. That's the start of the religious quest right there. And I think it's a live question for everyone on this planet. And I would say that religious quest, the quest to answer that question or get some orientation to that question, involves the same sort of reasoning as the marriage example. Okay, so this is the normal way that humans think about these things. Now, it doesn't mean the fact that it requires commitment, it requires faith. It doesn't mean we check our minds at the door. Okay, we think about things. We look for evidence. So in the religious quest, or in a quest to think about marriage and should I commit to this person, there are sources of evidence that we can all draw on. In religious quest, I have primary evidence in a religious worshiping community. I have the testimony of other people who've gone before and left their records and their experiences for me to share in. And I have the critical reflections of a community of people around me, right? And hopefully they are being critical and not just saying that everything I think God is saying and doing, just acquiescing in that, because we all know that great crimes have been committed in the name of God, and we rely on a critical community around us to some extent to, when we're kind of getting offline, bring us back on. So there's all kinds of checks and balances, and we're not checking our minds at the door, but in the end, scientific evidence, in the sense that we think of it scientifically, it's not compelling. It doesn't compel faith. And in the end, you have to take this step, and you have to make commitment, and that's an essential part of it, even in the absence of anything resembling scientific proof. And I think the stakes are high in this quest. I think that you might make a fool of yourself living a life believing in something that's not true. On the other hand, you might, as I believe, get in touch with the most fundamental truths about the universe and our role and our purpose in the universe. So I wanted to say that just as a way of introduction to my global take on the science and religion thing. And I've been wandering the halls of academia now. I've just turned 60 a few weeks ago, big birthday, one of these decadal birthdays that really make you stop and think. And I would say that I've looked at a lot of ideas and a lot of ways to look at truth, but in terms of the overall asking questions about meaning in this universe, I haven't found anything better than my religious faith as a pole star, a north star to guide me on that quest. And I really identify, and I'm going to quote Christian scripture here, and I don't mean to be exclusive by doing that. I know that there are multiple faith traditions here and probably multiple non-faith traditions as well. So when I quote Christian scripture, I'm not trying to be an imperialist. I'm just telling you where I personally have come from. So I identify very much with this quote from John 6. It's way late in this long chapter, and Jesus has just done some some very difficult teaching. And the text in John says at this many of his disciples wandered away. Okay, so some people left, and literally uses that word disciples. They drew back and no longer went about with him, and Jesus said to the 12, "Do you also wish to go away?" And Simon Peter answered him, "Lord, to whom would we go? You have the words of eternal life." So this is the source of wisdom, the source of inspiration, the source of salvation in Christian terms that I found, and that rings most true to me. And I think that science needs to inform all of our religious traditions. I think we all want to be scientifically literate. We all want to learn to think scientifically. But we have to realize which questions are appropriate for scientific methodology and which questions are most appropriate for other sources of wisdom that traditionally humans have gleaned on for millennia. And I just want to show you one other verse before I get onto the brain. I am going to talk about the brain now, though. Before I get onto the brain, I just want to show you, it's really interesting, this next quote, it just continues right on. I think this might be the 69th verse, it is. And after they say, "You have the words of eternal life. Lord, to whom would we go? You have the words of eternal life." Look at what they say. "And we have believed and have come to know that you are the Holy One of God." Now notice that does not say, "We knew and have come to believe that you are the Holy One of God." It says, "We believed and have come to know." So that to me, that captures exactly what we're talking about here, that in so many of our important decisions in human life, we have to think and gather evidence as much as we can, and feel and gather evidence as much as we can, and then we have to make a commitment, and we have to believe, and sometimes the knowledge comes after we make the belief commitment. Okay, so what about the brain? All right, so Peter has really introduced you to some fundamentals of the way neuroscientists look at the brain and think about the brain and think about sources of behavior in the brain. And I would capture all of this in what I would call the central dogma of neuroscience. Okay, this is the central assumption or central dogma. And I'm talking about dogma here in the same way that Francis Crick talked about the central dogma of molecular biology being the code in DNA that gets translated into protein. It's the result of a lot of investigation, in other words, and it also incorporates assumptions about how we proceed in neuroscience. And the central dogma here is that all of our behavior and all of our mental life, okay, including our sense of a conscious continuing self, is inextricably linked to the biology of the brain. Now, I chose my words very carefully here. I wrote this. I didn't pull this out of a textbook. And I chose my words very carefully here. You notice I didn't say determined by. There are a number of phrases that other neuroscientists might put in there, but what I'm said here is that it's inextricably linked to the biology of the brain. And Peter showed you a lot of evidence for that. He talked about the remarkable experiments, in the late 19th century of Fritz and Hitzig, stimulating different parts of the neocortex and showing that some very specific functions were localized to different parts of the cortex. He talked about Penfield's experiments where he stimulated the human brain of unanesthesized awake humans during neurosurgery and could elicit remarkably vivid first-person experiences just by activating the electrically sensitive tissue directly. There are many, many other examples that we could put up here, but all of the evidence that has accumulated over the last century and a half of active neuroscience investigation points to the reality of this dogma, that there's no part of our mental lives that do not depend in really important and precise functional ways on the biology of circuits in the brain. Now, that raises the question, and Peter again articulated this very nicely, what about free will? This usually isn't asked in professional neuroscience circles, and it's usually not asked within graduate circles. You usually have to get down to undergraduates before somebody will ask a question like this. Although it's on everyone's mind in and out all the time, and sometimes you hear it in the back corridors, but it's rarely brought out and discussed in neuroscience circles. One sort of funny quip that I heard about this, the answer to this question, what about free will? It's this quote here, "I'm not a fatalist, but even if I were, what could I do about it?" It's a way of dodging the question, right? And I want to tell you a little story here about a case that brings this all vividly to mind. And this issue about freedom and to what extent do we really have control, voluntary control over our behavior or not, is becoming increasingly pressing in the courts. And increasingly, neural data, brain scans, are being introduced as evidence that defendants have diminished or no responsibility. And they put a picture of a brain up there with these glowing blobs of color, and they say, look, my client's brain is different from a normal brain. Not playing with the same deck of cards you're playing with, and therefore can't be held responsible for this behavior. And that's being introduced as evidence of diminished or no responsibility, and therefore pleas for less punishment. Now, this is not a brand new issue. This has been with us, and the little story I'm going to tell you, I'm going to show you, it's been with us much longer than brain scans have been with us. And it's the story of this guy, Charles Whitman. This photograph was taken right after he left the Marine Corps and was entering the University of Texas as an undergraduate, and this was in about the early 1960s. And I'm guessing that no one here, knows who this is. Even in a room full of Americans, not that many people would recognize it. Peter here.
Well, I'm 70.
Oh, okay. All right. So this guy was the Texas sniper. This guy climbed up one afternoon into this tower, at the top of this tower at the University of Texas with a high-powered rifle, and he shot and killed 30 people on the ground before he turned the rifle on himself and killed himself. He wounded numerous others, and in fact, he had killed his mother and his wife before he went up into the tower and did this. And Whitman is a remarkable person in that he actually kept a diary of his feelings and thoughts leading up to this event. And you can just go out and Google Charles Whitman. You can document all this stuff I'm telling you. And this is a direct quote from Whitman's notes. He said several days before he climbs the tower, he says, "Lately I've been a victim of many unusual and irrational thoughts. I consulted Dr. Cockrum at the University Health Center and asked him to recommend someone that I could consult with about some psychiatric disorders I felt I had. I talked to a doctor once for about 2 hours and tried to convey to him my fears that I felt overcome by overwhelming violent impulses. After one session, I never saw the doctor again, and since then I've been fighting my mental turmoil alone and seemingly to no avail. After my death, I wish that an autopsy would be performed to see if there is any visible physical disorder." So here's a guy struggling with this issue about freedom and can I control my behavior or not control my behavior, right? And this is an even more poignant passage. "It was after much thought that I decided to kill my wife Kathy tonight. I love her dearly, and she has been a fine wife to me as any man could ever hope to have. I cannot rationally pinpoint any specific reason for doing this." And he left another note with his body. "If my life insurance policy is valid, please pay off my debts, donate the rest anonymously to a mental health foundation. Maybe research can further prevent tragedies of this type." And his brain was actually taken out and an autopsy was done after his death. And it turned out that Whitman had a tumor. And this tumor was right down here in a part of the brain that was impinging on the hypothalamus. I don't know if the hypothalamus is actually labeled here. The hypothalamus sits right around here, and it was impinging on the hypothalamus and also on the amygdala. And both the hypothalamus and the amygdala are structures that we know are deeply involved in the regulation of emotion and the expressions of behavior that reflect emotion. Did that tumor cause Whitman's behavior? We'll never know, right? Today, we can actually do brain scans and identify tumors like this, and there's some very interesting stories about interaction of brain pathology and criminal behavior. But we'll never know whether this happened with Whitman or not, and we won't know the answer for him. And even if he did have the tumor, we don't know whether it was what caused his behavior. But it's remarkable that he had enough insight. He sensed that something abnormal was going on with his brain, and that there was this war inside his own head. He felt these urges to commit behaviors that he had no rational control over. And he actually sought help for it, right? But in the end, couldn't come up with it. So then it says, this makes this even more poignant, right? How do we think about free will, and how do we think about the brain? All the questions that Peter raised, to what extent is our behavior the result of a highly mechanized process, a beautiful and wonderful machine, more sophisticated than any human-made artifact, but perhaps a machine-like entity nevertheless. And the question then that arises is, are any of us actually free, right? Or are we, in some sense, just like Whitman, that we have some kind of illusion of control. Whitman had no illusion of control, right? That's exactly why he went to see the doctor, because he knew control was slipping out of his hand. Or, you know, do we have some sort of illusion of control? But in reality, our behavior is programmed in exactly the same way that Whitman's is, just in different ways that are more the norm for human beings. So there have been, you know, several attempts to address this. You know, what is ultimately the ultimate model of human behavior, and where does behavior come from? And one here is bottom-up determinism. So this is the notion that all of this high-level stuff, all the folk psychology stuff that we typically describe human behavior in terms of beliefs and goals and aspirations, those are stories that our speaking hemisphere throws down on top of events, and that when we really understand human behavior, it will be shown to be the results of highly machine-like deterministic activity at the neural level. And when we really understand human behavior well, we'll be able to throw all those folk psychology descriptions overboard, and we'll really have ground truth at the neural level. So this is kind of a bottom-up deterministic view where you try to reduce all of this high-level concepts and psychologizing down to the neural systems, and you throw away or you eliminate the higher-level things. And I'm going to talk about that and talk about why I believe that's not right, as a neuroscientist, why I believe it's not right, and I'm going to conclude that's not so good. I'm also going to talk a little bit, very briefly, about the quantum brain, and Peter brought this up in his talk. And some people look for a resolution to this determinism problem through quantum mechanics and indeterminacy at the quantum level. And I'll say why I don't really think that's a very good model for free will. I will also talk briefly about this idea. This is something that's, you know, this was lurking in the background of a lot of the discussion earlier this morning. The notion that freedom, the definition of freedom, is that there are no underlying causes. And if there are underlying causes, if something causes me to pick chicken rather than beef for dinner, or if something causes me to spend one night a week working at a food bank, if something causes that, then it's not free. Okay, and lurking under a lot of our discussion this morning was this particular notion that if there's a cause, then it's not free, and the corollary being that freedom equals uncaused. Okay, and I'm going to argue that this is not right, even though we all have tendencies in the direction. I fall back into thinking like this frequently, and it's very difficult to break out of it. But I'm going to argue that that's something that we need to break out of. And I'm going to argue for, so these three things I'm going to argue against. And what I'm going to argue for is the notion that what we really want intuitively by freedom, what we mean by freedom, is the ability to be self-determined or to be autonomous. That the causes and the reasons for our behavior, to a large extent, come from inside us, and that we're not at the complete mercy of events outside us. We're not coerced in some senses by events outside us. And while acknowledging that much of our behavior comes from neural processing down at very low levels that we are not aware of, and I can give you strong evidence for that if you want strong evidence for that, while we admit that, we also believe that these higher level constructs like beliefs and values and aspirations have a causal role in our behavior as well. And those are quintessentially ours. My memories, my history, my beliefs, my values, my aspirations. If our behavior is caused by those things, then that's self-determination. And I think that's what we really want by freedom. And if neuroscience in the end can deliver that, then I think some of our conflicts on this issue dissolve. Not all of them, as you no doubt will point out, but some of them. And just to say a little bit more about this self-determination, I think this is where we want to get. My behavior is caused at least in part, and I say at least in part because I know this is not the entire story, but at least in part, there is a place there in my behavior that it's caused by my beliefs, my values, my memories, my goals, and my aspirations. And also, I would include this, although I won't really talk much about this, because as Dennis Alexander said, I think consciousness is the toughest problem here for neuroscientists. But I also believe that, and I can give you some reasons why I believe this, that conscious, rational thought plays a causal role in my behavior. Now, there's a strong movement in some neuroscientific circles to believe that experiments done show that consciousness is a late fact, a couple hundred milliseconds after the neural events that actually determine behavior. And these neural events go along and determine behavior, and then we become conscious of that, and we make up a story that we decided to do this. And some of those experiments have pretty powerful evidence, but I can tell you why I think that there's a role very much for thinking that consciousness plays a causal role in behavior. But what consciousness is exactly, I don't know, and we can talk about more if you want to later. Okay, so let's deal with this bottom-up determinism thing. So briefly, I've described this already. This is the notion, ultimately, that all causation, anything that has a cause, goes back to the four fundamental forces in physics, right? Electricity and magnetism, gravitation, the strong nuclear forces and the weak nuclear forces. Those are the four causes that we know. These are forces that do work in physics. And the notion is that those are where real explanatory power lies, and everything that lies on top is sort of, physicists like to say, in science there is physics. Everything else is stamp collecting, right? I don't believe that. I'm a biologist. Okay, so this model of reduction, that we can ultimately reduce all these higher levels down to fundamental physics. This is actually a fairly recent model to some extent. It was stated really clearly by this guy Ernst Nagel, working back in the late 40s and through the 50s and early 60s. And this is the classical model of reduction that Nagel laid out. He says that one theory, okay, a theory at this level, like maybe theory at a psychological level or a theory at a neural level, is reduced to another when it becomes possible to define the theoretical terms of the first, that is the higher level. You can define those theoretical terms by the theoretical terms of the lower level, and to derive the first theory from the second. So this is a very strong view of reduction, right? That if you can define the theoretical terms at the high level in terms of those at the low level, and you can derive the high level from the low level, then there's no more work for the high level to do. You can really get rid of it because you've got more fundamental truth at the lower level. And this is the classical sort of theory of reduction. It was obviously inspired by physics. I think it's questionable whether this has ever actually been achieved in physics, but certainly in biology, I don't know that it's been achieved. Now, these quotes here from Carl Craver's 2007 book, Explaining the Brain, which I think is an excellent book, though it's written for philosophers of science, so it's a bit dense for people like me. But Carl says that in talking about the reductionists here, this sort of eliminative reductionism, that he calls these people metaphysical fundamentalists. I kind of like that phrase. And he says the metaphysical fundamentalist argues that non-fundamental things, that is things at a higher level, have no causal power over and above fundamental things. They believe roughly that everything has a cause at the fundamental level, the lowest level, and that nothing has more than one complete cause, and if so, it follows that no non-fundamental things are causes. So by no non-fundamental things, this includes things like your beliefs, your aspirations, your goals, your memories, that fundamentally those things don't cause anything. They are not causes. The real causes lie at the lower level. So this is this bottom-up deterministic or eliminative reductionistic point of view. Now I have problems with this point of view, and they're several-fold. My first problem is it just doesn't work in real life. So nobody goes to the restaurant and the waiter comes up to you and asks, will you be having the beef or the chicken? And you said, well, I've become a bottom-up kind of guy. I've been convinced that bottom-up determinism is real, and I don't need to make that decision. My nervous system is going to do it for me, and I'm just going to sit here and wait for that decision to happen. I mean, if you do that, you're never going to get dinner, right? At some point, the waiter gets impatient, and you say, well, maybe I do need to make a decision. Maybe I do need to engage here. And so this philosophy, which is really what it is, it's not science, it's really a philosophy. It doesn't work for me in real life, and I'm very suspicious of any philosophy that doesn't work in real life. Okay? If it doesn't apply, if I can't apply it, I'm suspicious of it. It doesn't describe what neuroscientists actually do. So in biology, and in general, and in neuroscience in particular, which is what I know best, no level has ever been completely reduced to a lower level in the terms of being able to define theoretical constructs in terms of each other, and in terms of being able to derive a theory from another theory. We have interlevel interactions and associations, but in terms of the strong form of reduction, it's never happened, okay, in neuroscience for certain, and maybe probably in all of biology. There's also this regression issue about whose fundamental level is actually fundamental. So there are neuroscientists who will say that we can reduce the psychology to the neurons and neural circuits. those same neuroscientists will get very, very suspicious if you start trying to take their neurons and neural circuits and saying, well, that neuron's not really real. It's just a collection of macromolecules, and we can reduce this stuff to genes. And of course, the geneticists are almost the worst fundamentalists of all. The genetic power is where the real causal power lies. And they'll get very nervous if you start talking about, well, really, that's just chemical bonds and atoms. Everybody wants to protect their level where they're working, right, or where they intuit that the strings of power lie. And of course, when you regress, ultimately, you get down to the most fundamental scientific description we have of the world, which is quantum mechanics. Okay, I mean, that's the lowest level. And another problem for this kind of fundamentalist reduction is that when you get to that lowest level, when you get down to basic physics, the world is arguably acausal. And that means there are no causes. So Bertrand Russell wrote this famous essay called On the Notion of Cause, Proceedings of the Aristotelian Society in 1913. And Russell, with his characteristic incisiveness and wit, says, in the advanced sciences such as gravitational astronomy, the word cause never occurs. He says, Dr. James Ward, this is a philosopher writing, in his Naturalism and Agnosticism, makes this a ground of complaint against physics. The business of those who wish to ascertain the ultimate truth about the world, he apparently thinks, should be the discovery of causes, yet physics never even seeks them. To me, it seems that philosophy ought not to assume such legislative functions, and that the reason why physics has ceased to look for causes is that, in fact, there are no such things. The law of causality, I believe, like much that passes muster among philosophers, is a relic of a bygone age, surviving like the monarchy only because it is erroneously supposed to do no harm. I wish that I could make up things like that, but I can't. His fundamental point here is that the equations in physics, F equals ma, one of the most basic of all, you can put anything on the left side of the equation or anything on the right. You can just as easily say m equals f over a, or you can say f equals f over m. You can rearrange that equation any way you want to, and there's no sense that force is causing acceleration, no necessary sense, or that acceleration is causing force, or whatever, just equation. There's one exception, which is in thermodynamics. There is an arrow of time where entropy always tends to increase. But in general, at that lower level, things are arguably not causal. So the last point I have up here, which is, are my problems with this fundamental reduction, is that quantum mechanics is impoverished, in my opinion. Okay, so if we really believe in the eliminative reductionist agenda, in principle, we could write a quantum mechanical wave equation, a Schrodinger wave equation, for the motion of every atom in this room for the next 10 minutes, 20 minutes, whatever. Pick your time course. Now, it'll be a probabilistic thing because quantum mechanics is probabilistic. It includes randomness and probability. But in principle, if we're smart enough and if we had enough computing power, we could write that equation. And the notion, the fundamentalist notion, is that that's then when we're in touch with ground truth. And we can get rid of all that stuff on top. Okay, we've got the ground truth right here in the wave equation of what's going to happen in this room over the next 20 minutes. And my problem is that the wave equation knows nothing about summer courses. The wave equation knows nothing about people. It knows nothing about curiosity. It knows nothing about argumentation. It knows nothing about hunger. The wave equation is just atoms in motion. And I would say if what you really want to know is the motions of atoms in the room, then maybe the wave equation is where you want to go. But if you want to know about people, and if you want to know about their motivations, and you want to know why they behave the way they do, I don't think the wave equation is where you want to go. I think it's impoverished. It's not wrong, it's just impoverished. That's all. Okay? So, so these are my reasons for rejecting this bottom-up deterministic view of the world. And you may wonder why I've gone on at such length to reject something that maybe all of you inherently reject. I think I've gone on at such length for one reason, because it's powerful, and two, because most of my professional colleagues, I think, have this deep in their hearts and souls somewhere when thinking about the world. I mean, I just had dinner with one recently, a really, really smart neuroscientist. And once we scratched at this a little bit, this is what he was about. And he said he readily acknowledged this doesn't work for my daily life. I don't run around thinking this, but I guess in the end, that's what I believe about the world. And that's why I feel like I need to lay these things out. Okay, so I don't know exactly what Sean Polkinghorn's talk was on Monday. I wasn't here on Monday. But I've heard John talk a bit in the past, and John seems to have some sympathy for the idea that quantum mechanics, and the fact that quantum mechanics is probabilistic, and creates room in the brain in some sense for spontaneity and for freedom. I'm skeptical of this idea, and I'm skeptical about it for two reasons, one scientific and one more philosophical. The scientific reason is that I have talked with as many biophysicists as I know to talk to, I mean really high quality people, and most people agree that the macromolecules, the ion channels that are responsible for the current flowing inside of membranes, genes, other macromolecules, they are too large for quantum effects to be, they have too much mass for quantum effects to be existent or prevalent, at least in the nervous system. Quantum mechanics, it is more applicable at microscales, and the notion is that the macromolecules that make up cells are too macro for that to happen. So that's a scientific reason. Now they say that there's noise in the brain, there's stochasticity, that's another word for noise, or random noise. There's stochasticity in the brain, but it's not quantum mechanical, it's thermal noise, okay? So, and that noise can play a purpose, by the way, which we can talk about if you want to. The more philosophical reason for thinking that quantum mechanics is not going to be deeply informative to us about brain function was pointed out by Pat Churchland in her 2002 book, Brainwise. And Pat says, random, uncharacteristic behavior is not a paradigm for free, responsible behavior. Okay, so the random behavior, the probabilistic aspect of quantum mechanics is what she's talking about here. Behavior that has internal causes consistent with our history, our motivations, preferences, goals, beliefs, etc., are properly considered free. Random behavior would convince me that someone is messing with my mind. Another way to talk about this is that when we go out to the street, to cross the street out there with all these crazy drivers here in Oxford and coming down the wrong side of the road all the time, you want to look down the street. Cambridge.
Wrong city.
Wrong city. Sorry. Wrong city, wrong side of the road. When you go out and get ready to cross the street, you want to look and you want to see oncoming cars with essentially 100% reliability if possible. You don't want to get down to the 63rd time and have some random quantum mechanical event in your brain happen and have you fail to see the car, right? We want mechanisms. We want our visual perceptual mechanisms to be reliable. We want our assessments of social signals to be reliable. And when those things fail us, we get in trouble with either physically or socially with our fellow human beings. And so this is a more philosophical reason. The randomness is not in and of itself any more meaningful than strict bottom-up determinism, okay? And Pat quotes Hume. She says that Hume made the deeper and more penetrating observation that an agent's choices are not considered freely made unless they are caused by his desires, intentions, and so forth. And this goes back to my definition, right, of self-determination or autonomy. When we think about freedom, what we're really thinking about, in my opinion, is that our actions are caused by these things about ourselves that we perceive to be real. Our history is embodied in memory, our beliefs about how we want to live our lives, our values about how people should be treated. These are the things that constitute freedom. It's not random departure from anything that constitutes freedom. So I don't really think the answer to these problems lies in the direction of the quantum brain. Okay, so these are kind of two standard approaches that I'm sort of saying I don't think they work. Now this one is, this is the one that I've said I think is lurking around in a lot of our brains, including my own all the time, thinking that if something is caused, it can't be free. And I think I've gradually over the years come to disbelieve this. I actively now fight against this equation. And one of the reasons I fight against it is just because of this dogma, central dogma of neuroscience, the fact that the more we learn about the brain, the more we electrically stimulate different parts of the brain, the more we learn that activity in specific parts of the brain actually, you make that part of the brain active and you will cause emotional responses in people. We learned that if you have damage to specific parts of the frontal lobe, you get very specific personality changes. And so the more we learn, the more we become convinced that all of our behavior and our mental lives are inextricably linked to the biology of the brain. So that's one reason that I've gotten away from this what I consider somewhat, it's intuitive, but I think in the end it doesn't work, that freedom means that things are not caused. I reiterate again that I think when we talk about freedom, what really matters here is what counts as a cause, and whether our beliefs and memories and aspirations count as causes. And I'll come back to that idea in just a minute. So I'm left with this self-determination or autonomy thing, and I want to give you a little sketch for how I believe we should be at least starting to think about this. Now, I don't have great answers. I don't have final answers to these things, which is not surprising. These have been puzzles for millennia to human beings, but there are some ways that I think we can think, and some of these were anticipated by Peter in his talk, and I'll point out that I put neural systems up here before the discussion at the end of the talk. You know, maybe instead of thinking about the brain as a machine, we should think about it as a neural system. I'm down with that. And this I've already alluded to. The key issue here is what counts as a cause. Are all causes at that fundamental level of physics, or are there higher levels of organization that we can properly think of as having causal action in the world? And that, to me, that's the critical question. How you think about causality and what counts as a cause. Now, there are a couple of things that lead me to think that these higher states of organization of the nervous system legitimately count as causes. Higher states of organization of the nervous system that I think equate to our beliefs and our values and our aspirations. And I think they are legitimately considered causal. So one observation that tilts me in that direction is this one, and I don't even consider this controversial. And it's a simple statement: wholes are more than the sum of their parts, and it's by virtue of, I've learned that phrase is really big for philosophers, by virtue of the organization of causally interacting components. Wholes have causal powers that parts do not, okay? If you take the components of an airplane and stack them in a pile, that group of components cannot get off the ground. If you assemble them together with the right organization of parts, then that airplane can fly from London to New York. If you take a lion apart and stack its parts on the ground, that stack of parts has no power to kill me. But those parts assembled in the right way have the causal power to kill me. Okay? So this is just obvious to me, that wholes have causal powers that parts do not have. And the causal power comes out of this organization of their components. And it's that organization that really endows the stack of parts with causal power. So that points me toward these higher levels and having real causal powers. Here's another one. And it has to do with this word organization. If we start unpacking this word organization, which Peter did a bit in his talk, and which many of you continued unpacking during the question and answer period, we get down to this word here, the I word. Remember, we struggled with that during the question and answer period. But organization in the abstract information is reducible in individual instances down to very low levels, but not in the general case. And what I mean by that is what we've already discussed today. What I mean by that is, for example, that the program, PowerPoint, that's running on my computer right now, in this particular instance can be reduced to a certain pattern of transistors inside the guts of this particular machine. But if I quit PowerPoint and I fire it up again, it's going to be the same program, but it's going to be realized in a completely different set of transistors. So they'll probably be overlapping, but certainly there will be some different transistors. And what's constant between those two runnings of PowerPoint are the pattern of organization, the ons and offs, the ones and zeros across transistors, but it's not the exact same transistors. And as Peter pointed out, we can take this program and run it on another computer so that there's no transistors in common, yet it's the same program and it's doing the same work. And it will cause the same inputs and outputs to come out of the computer. So to me, that level of organization, or in the abstract, it's that word information, is reducible in an individual instance, but not in a general sense. And this, you see this over and over and over again. So if you just think about any tune, like the Star Spangled Banner, the United States National Anthem, that tune can be played on a violin, it can be played on a piano, it can be played on a cello, and it's recognizably the same tune, even though different physical instruments are being struck. You can even take it on the same instrument and play it in a different key, and it's the same tune, even though completely different What do you, the things on the piano? The keys on the piano are being struck. So different keys are being struck, but it's the same tune. You can even change it into a minor key versus a major key, and it'll be the same one. So this points to me, for me, toward the reality that these higher levels of organization have an existence about them and a givenness to them and causal powers that are reducible in any given occasion to the actual transistors and the actual notes, but not in general. It's the pattern itself where the real information lies. So I think that's really important. And when we had that discussion that broke out about, does this mean you're into Platonic idealism and how these two worlds interact or whatever, the one thing I would have added right there is that Microsoft Word can exist in this computer or a different computer. It can exist on a memory, in a disk, a hard disk. You can even type it out. It's hundreds of thousands of lines long now of code. But if all those physical instantiations cease to exist, then as far as we humans are concerned, Microsoft Word would disappear from existence, right? I don't think it lives out there in an independent, ideal world. It lives on real physical instantiations, right? And that's a key concept to keep in mind as we go forward. Okay, so from this point of view then, fundamental laws of physics constrain but do not determine the behavior of a complex system. So physics constrains the computer. Nothing can happen in the computer that physics doesn't allow, but physics doesn't determine what happens in the computer. All right, if anything determines it, it's the software that gets loaded into the computer. So, neuroscience explanation. If we start taking some of these ideas and working with them in the brain, we'll find that neuroscience explanation is intrinsically multi-level. What do I mean by that? All right, let's take an example. So I'm going to take you into the world of neuroscience a little bit. It'll be sort of at a very high level. I won't show you any data. But neuroscientists study psychological phenomena or behavioral phenomena like long-term spatial memory. So long-term spatial memory is what you use when you get off the bus and walk to your home, or when you drive from one town to another, a route that you know well. You're using long-term spatial memory. If we want to study this in a laboratory and the neural mechanisms underlying it, we'll take some laboratory animal, frequently a mouse, who will be navigating a maze. It can be a maze in the water where the mouse is swimming around, or it can be a maze on land, a T-maze, or some kind of maze where he's solving it to get a reward. And we know that the ability of the mouse to navigate that maze and to remember the configuration of the maze from day to day depends on a particular structure in the brain called the hippocampus. And inside the hippocampus, the neural systems have a spatial map. So any environment that the mouse is familiar with, there's a map in the hippocampus of that particular environment. Now, how does the mouse form that? The first time he gets put in one, a new maze, he doesn't have a map of it. Well, we know that there's this mechanism that lies at the heart of much learning. It's called long-term potentiation, or LTP. And LTP is a mechanism by which one neuron strengthens or weakens its connections, its synaptic connections to other neurons. And LTP and many other plasticity mechanisms are going on all the time. So if you remember, for example, anything about this lecture when you walk out of here and you remember it tomorrow, it will be because your brains have changed. The strength of synapses between your neurons have changed strength. In other words, we're messing with your brain right now. We're physically changing your brain right now. Literally physically changing your brain. If we don't change your brain, you won't remember anything tomorrow, and you will waste your time. Now we know that long-term potentiation, if we go down to a lower level, long-term potentiation depends on NMDA receptors, these special kinds of ionic current transducing receptors that lie at many synapses in the brain. And if NMDA receptors don't get activated, LTP will not occur, and learning will not occur. And we know that NMDA receptors, more of them can get put into the membrane, or some of them can be taken out of the membrane due to activities at the genetic level that produce more of these receptor molecules. Now, here we've looked at 5 different levels, right? A water maze, a behavior level, a structure level, a synaptic plasticity level, a molecular level, and ultimately a genetic level. So we've got 5 different levels there that are part of the causal story of long-term spatial memory, okay? And what I'm going to argue is that none of these levels is privileged. They are all critical, okay? Because we have never been able to reduce one of these completely to another one and throw the other one away. So one reason we've never been able to do the reductionist model, the complete reductionist program, and I don't really think we will. But a second thing is that our ultimate notions about causality, in my opinion, are very practical notions about causality. Causality in practice really refers to where can you go into the system and manipulate the system and cause a change. Okay? And if you can go into a particular point in the system and you can manipulate it and cause a change, then you're in touch with causal reality. And it is a fact that you can manipulate the system at any of these levels and cause changes. So we can put the mouse in a different maze, and we can cause changes in this spatial map. We can cause changes in LTP. We can recruit it or suppress it. We can cause changes here just by the manipulation at the behavioral level. We can go down and manipulate at the genetic level, so we can make knockout mice that lack certain genes, and you can show that at the behavioral level, they're deficient in learning. We can go in the hippocampus and inject little anesthetizing boluses of pharmacological agents. We can anesthetize the hippocampus, and the mouse will be unable to work the maze in front of him. But as soon as that anesthesia wears off, the mouse can run around again and know the maze. So we can intervene at all of these levels, and we can change what's happening at the other level. And this is a crucial concept, I think, of mutual manipulability. So when you have layered structures like this and layered interlocking layers of causality, you can go in and manipulate at any level and affect all of the other levels. So I would say that causal relevance is not solely at any one level here, but causal relevance runs up and down. And I say that as a neuroscientist, okay? And this to me is key. This gets to the heart of the matter, because this is long-term spatial memory up here, but it could just as easily be a belief. It could just as easily be a goal. It could just as easily be an aspiration. And like we keep saying, the critical question here is what counts as a cause? Are the only causes down here, but whoops, genes don't really cause things. In the fundamentalist point of view, you got to go down to physics to get causes, right? You know, what are you going to do? I mean, somehow that seems so impoverished down there at the level of physics. It's beautiful, it's spare, it's elegant, but it's impoverished. So somehow the secrets must lie up here. Well, which level do they lie at? They are not localized at any single level. Okay, these levels are all interacting with each other all the time. Okay, so I've punished you here with quite a few things, and I'm going to try to zoom back out in the last minutes of talking. I want to say, what does all this mean? And I can see little thought bubbles over some of your heads. I lost track. What's at stake here? Why is he going on about hippocampus and LTP and all this stuff I've never heard of? Well, here, the key thing is about this self-determination autonomy. If I'm right, and I may not be, but if I'm right, that the key thing here, that what we all sense and mean by this word freedom, you know, that we invest so much in, and our religious traditions invest so much in, and our legal traditions invest so much in, is that in some sense, self-determination, the causes lie within the self, and that there's autonomy, and that we have responsibility for our choices. And the key issue is what counts as the cause. And the gist is that we have to find a way of talking about non-fundamental causation. And if we can find a way to talk meaningfully about non-fundamental causation, all right, the causation resides simultaneously at all of these levels, and I think we have to do that, then we can take mental causation seriously, right? Because if the causation lies at multiple levels, then our beliefs are causal, our goals are causal, our aspirations are causal, and they're not just illusions. They're not just froth being carried along on top of a wave, but they're real actors, what John Polkinghorne and Nick Beale would call first-class citizens in the causal description of behavior. I like that. Okay, now, hear me well. This is not to say that bottom-up causes are unimportant. Explanatory relevance runs both upward and downward, right? I've got these arrows going in both directions. So our behavior is shot through and through with effects of things going on at lower levels that we have no conscious awareness of at all. And if you want me to document that, ask me in the question period, and I will document that for you. I have a great slide to document that for you. It's the most astounding slide I've seen published in scientific literature in the last 2 years. So somebody can ask me about that if you want to hear about it. Okay, so let's look at a couple of examples of bottom-up and top-down kind of language. So here's classic bottom-up language. So this is Richard Dawkins. All of you know who he is. Most of you, some of you have probably read his classic book, The Selfish Gene, from 1976. And he presents genes as the real actors in life, and we as human beings are merely along for the ride. So Dawkins says, Genes swarm in huge colonies, safe inside gigantic lumbering robots. That's us. Sealed off from the outside world, communicating with it by tortuous indirect routes, manipulating it by remote control. They are in you and me. They created us, body and mind, and their preservation is the ultimate rationale for our existence. That's your rationale for existence, is preserving your genes. Now, one of Dawkins' colleagues at Oxford, that is Oxford, Dennis Noble wrote in his book, this is a quote from his book, I got these two quotes from R. Louis at Oxford. Dennis Noble wrote this book, The Music of Life, and he's obviously paraphrasing and mocking Dawkins here to a little bit. And what Noble says is genes are trapped inside huge colonies, locked inside highly intelligent beings, molded by the outside world, communicating with it by complex processes, through which blindly, as if by magic, function emerges. They are in you and me. We are the system that allows their code to be read, and their preservation is totally dependent on the joy that we experience in reproducing ourselves. We are the ultimate rationale for their existence. So this is looking at the same data about the world, right? But it's looking at it in two very different ways. One is looking at it very much from the bottom-up perspective, and one from the top-down perspective. Here's another example. I was extremely impressed when the Lasker Prizes were announced in 2006. The Lasker Awards are sort of an American medical Nobel. Many Lasker Award winners, like a third of them, have gone on to win Nobel Prizes, something like that. And in 2006, this article appeared in the New York Times that a psychiatrist was among the 5 chosen for the Lasker Medical Award. And it was this guy here, Aaron Beck, who's a professor of psychiatry at the University of Pennsylvania. And what he did, his claim to fame, is that he invented cognitive behavioral therapy. Now, many of you have heard of cognitive behavioral therapy, right? This is arguably the most documented, the most effective documented psychotherapy in the world today, and it's a tool that's used over and over again for treatment of many psychiatric disorders. And Beck invented this back in the 1970s or something. Does it say in here? It doesn't say right here, but sometime in the 1970s, I believe. And what we now know, and this was a well-known paper, it was published in a great medical journal, the New England Journal of Medicine. And what this paper documents is that people who are suffering from really acute depression are treated most effectively with a combination of serotonergic reuptake inhibitors, so common antidepressant drugs, and cognitive behavioral therapy. So they did a very highly controlled study where one group of patients is treated with the drug alone, one's treated with the behavioral therapy alone, and one group received both. And documentation, the two work better together than either one works alone. Okay, and this is shown not only in adults, but in this, I guess I didn't put it in here, I only have one, but it's been demonstrated for adolescents as well. All right, well, what's the significance of that? The significance of that is that the drug is something you take that influences the low levels of the system. It influences the serotonin neurotransmitter system, okay? And that affects people at the behavioral level. That's a bottom-up influence, and it changes emotional tone. But cognitive behavioral therapy is very much a high-level intervention. In fact, Beck himself calls this cognitive restructuring. That's how Beck talked about it. You're changing the patient's beliefs about the world, okay? So he's intervening at the level of belief. The drugs are intervening at the level of serotonin. They both work, okay? And to treat patients well, to understand human behavior well, and to treat patients well, we don't have to choose between those. We want to take both realities into account. And the bottom line here is that beliefs matter, okay? Beck was all about restructuring beliefs, and what we believe about the world matters in our behavior. Beliefs are a causal player in behavior. And here's a guy who knew this well. This is Leo Tolstoy, and this was, in some people's opinions, his masterpiece, War and Peace. I've never made it through the whole thing, I confess. But I do know that at the ultimate scene at the end, his protagonist, Pierre, is facing firing squad. And Pierre is sitting there thinking about the tangled stream of events that led to him being before the firing squad and facing the end of his life imminently. And Pierre is asking himself, who was it that had really sentenced him to death? Where did the responsibility lie? Where was the cause? And he's trying to do this thing we're trying to do. We're trying to say, what is the cause? Why did I arrive at this end? And Pierre, in the end, realizes that it didn't lie with those guys about pull the triggers. And it didn't lie with any individual, completely with any individual along the way. But it was a system, and in Pierre's words, it was a concurrence of circumstances, or in Tolstoy's words, it was a concurrence of circumstances. So this is, Tolstoy captures here very nicely in this example what I'm trying to talk about here with system causality. And that it's a mistake to try to pin causality down to any one point in a system of circumstances, but that you have to take the whole system into account in order to understand the behavior of any complex system. So I'll close just with this point here, that understanding the nature of human freedom, I think, is the most important problem facing the neurobehavioral sciences. And I don't think this is going to be solved in my lifetime, but I think there are some ways to think about it, but I don't think neuroscientists are terribly good at thinking in this way. You see a lot of pretty naive pronouncements by neuroscientists in the press about this is true, this is true, this is true, this is not true about consciousness and free will, and I think we know so little at this point. It's crazy with some of the things that get reported. But understanding this is important for obvious reasons of human dignity and social responsibility, but it's also important for science itself. Science is based on the notion that we can, as scientists, think rationally about the world, that we can do experiments, that we can obtain objective information, and that we can conduct future experiments on the basis of that objective information. And if we fail, if ultimately, or not ultimately, I don't think it will be the case ultimately, but if at this particular point in history, we're trying to say that beliefs and aspirations and goals and rational thought are constructs that we can throw away when we really understand the system, I think we undermine science itself. And that's illustrated by this quote. This is one of my two favorite quotes from J.B.S. Haldane, who was a geneticist in the middle of the 20th century, is a Brit, actually. And Haldane says, if my mental processes are determined wholly by the motions of atoms in my brain, that would be a quantum mechanical view, I have no reason to suppose that my beliefs are true, and hence I have no reason for supposing my brain to be composed of atoms. Kind of highlights the tension here. So I'll stop with that. I don't think that I have answered these great questions. I think that I have, my goal is to throw out some cautionary warnings about certain ways that it's easy for us to think about the problem of freedom and human behavior and the root causes of human behavior, and maybe suggest some ways going forward that we can keep our eyes on that might be more productive perhaps than some of the ways we've tried in the past. So thank you very much. I'll be happy to answer questions.
Great, thank you very much, Bill. Can I start by saying, can we see that slide, which was the most interesting scientific result in the past 2 years? I mean,
Yes, you can. So this is from social psychology at Tel Aviv University, and it's an astounding slide. It's a study, a classic social psychology study of decision making by judges in Israel, and these are judges who are deciding on pleas for parole raised by convicted criminals. And these judges hear these pleas, and it's a single judge, and they're sitting there and they're hearing about 20 or 30 of them a day. So they're just going like this, about 10 minutes per person. And they're making decisions, and they start at a set time and they end at a set time. And they have two, and this is very highly routinized, which is the only reason you could do this study. They have two food breaks in the middle. Okay, one about a third of the way through and one about 2/3 of the way through. And these guys studied the proportion, and they did this over about 30 Israeli judges. So this is solid data. And this is the proportion of favorable decisions in favor of the people asking for parole against the ordinal position, in other words, where that person's plea was heard during the day. And this is astounding, right? Because at the beginning of the day, there's about 65% judgments that are in favor of the person who's making the plea for clemency. And then that percentage goes down to nearly zero just before the first food break, right? That's the first food break. And after the food break, it goes back up to 60%. And then it comes down to about 10%. And this is averaged across 30 different judges. Okay, this is not one person. And then it goes up again after the second food break to around 60. and then it's down here for the rest of the afternoon. So if you're one of these prisoners asking for clemency, you do not want to be here. You do not want to be here. You do not want to be here. You want to be first thing in the morning or right after the food break. Now, this paper appeared in Proceedings of the National Academy of Sciences. We actually contacted these people to find out if this was for real and if publication of these data had made any difference in Israel. I mean, the moral of these data is you might as well throw those courts away and just throw dice. Dice would be just as this, right? So, and by the way, they did lots of controls here. So if you plot seriousness of the offense against ordinal position, it's flat. If you plot time and rehabilitation as a function of ordinal position, it's flat. If you plot multiple offenses, cases with multiple offenses as a function of ordinal position, it's flat. So none of those things explain this pattern. And you know, in legal circles, apparently they have a saying that is, justice is what the judge ate for breakfast this morning. And this is disturbing, right? I mean, we're accustomed to seeing social psychological results that show things like this, that our behavior is primed by things we're not even aware of, right? We're accustomed to that. But usually those axes read 57% and 53% at the lowest part. And you mass a lot of data to become statistically significant. And we all say, okay, yes, I know I'm subject to this bias and this bias and this bias. But these numbers are astounding to go from 60% down to 10%, something like that. I mean, I've never seen an effect this big before in any social psychology literature. Isn't that amazing?
Amazing. Yeah. And now you know why, you know these Faraday course questionnaires, we get feedback forms. You know why we encourage people to fill them in right after lunch on Fridays.
Exactly.
I'm joking.
When this paper became well known at Stanford, our neuroscience graduate students, before their quals or they started serving coffee and cookies to the faculty who were. That's the truth.
Wow. Fantastic. Okay, over to you for questions and discussion. Please, sir. Yes.
I think because
yes.
I think we need to distinguish, as Peter distinguished, between epistemic reductionism and ontological reductionism. Of course, no one would deny that there are different levels of conceptual schemes, if you like, that you use different concepts at this level and down there are different others, and you can come back, and they are not reducible to each other.
Yeah.
That's fine if you are looking epistemically.
Yeah.
But ontologically, you can't say that ontology here is something, at higher level is something else, and they are not reducible to each other. Because the reality is one thing. There is one chair that they are not different things. So unless you say different level of existence, so spiritual and material things. So I'm still not convinced that there are different levels of existence or ontological levels. But conceptually, that's fine. And what I think
every Wednesday, it's the fire alarm.
It's the practice fire alarm, which should go up at 12 o'clock. It's 10 past 12, so I sort of think that's okay. Is it, what's today? Wednesday?
Yeah, Wednesday is the normal time.
Wednesday normal time. But being influenced...
Normally it goes off very soon.
There you go. There you go. Sorry about that. We should have warned everybody that Wednesday's fire alarm. And please carry on. Thanks. That'll get edited out of the film. Don't worry.
Sometimes to
Yes.
So we talk about dual aspect monism in the previous session.
Yeah.
Of course, there are different aspects of understanding things, but there is only one thing there, and the question is that is it material or immaterial, or is there free will, or is there soul there? So this is an ontological question. That is one question which I had to ask, and the other is that you mentioned that there are different levels, and higher levels can have cause on to lower levels, and there are interactions. I think what is you can look at other ways. Actually, maybe fundamental reductionists say that you are not interfering at the higher level. Your cause can be explained at the lower level. So what in reality goes on is on the lower level. But you can put a framework and speak on the higher level. But ontologically, things are going at the fundamental level. That's the question.
Yeah. Okay. So I agree with you that there's a important distinction to be made between epistemic use of levels versus ontological. And I'm not a philosopher, so this is not my real trade. And I certainly would say, I would agree with you that at the epistemic level, distinguishing among the levels is absolutely critical for human understanding. And I agree with you that whether these things are separate ontologically, whether the higher levels have some independent, I hesitate to use that word independent, but have some reality of their own over and above the atoms that compose them, I agree that that's a more tendentious question, a more arguable question. But my answer to that question tentatively is yes. And it's for very simple reasons. I mean, you're exactly right that in any one time that PowerPoint comes up here, it is reducible to one particular set of transistors. The next time it comes up, it's reducible to another set of transistors. So for any one instantiation, it really does have one set of transistors. But the question, it seemed to me like from an ontological point of view, is whether when that thing comes up multiple times, and every time it comes up, it's a different set of transistors, but it's in a particular pattern, does that pattern have ontological status? Or is ontological status only given to the individual realization on individual tries? And I have to ask for help from some philosophers here. To me, I take that seriously, and I refer to PowerPoint all the time as an independent entity. You know, whether it is to some extent on this computer, it's written down, or I'm going to download it from another website, it's a thing that we talk about, and a thing that we pay money for. And it's not, we don't pay money for epistemic constructs, right? We pay money for things that will do work for us. And so I tend to give it ontological status. Though, as I said early, I don't think it's out there in some world of ideals that's detached from physical instantiations. If all physical instantiations of PowerPoint were lost simultaneously, it would be lost forever. So I take the ontological thing seriously. Now your second point about causes, again, it's a good point, it's a deep point. That if I go and manipulate the hippocampus of that mouse, so I anesthetize it, so I'm manipulating it, but I'm doing it at the organ level, the hippocampal level, that ultimately all of that can be seen in terms of manipulations at the four fundamental forces of physics, right? I mean, there is a logic to that. We have to talk about boundary conditions, right? So boundary conditions are very important in physics. What's the extent of the system that you're looking at? And once you establish the boundary conditions, then physics is very, very powerful. A larger question there is who establishes the boundary conditions, right? What are they? And boundary conditions can change, and then the function of the system gets viewed in a very new light, even though the physics stays the same. So in some ways, it's really the boundary conditions that are important. But again, we have people who know physics here better than I do.
Peter Van Invader, did you want to comment at all on that first part? On
Yes, we actually have a
or do you want
metaphysician
to
here.
keep your hope fire to this afternoon?
Well, anything I could say would be dialectical. I guess I'd ask, well, what do you think to say about the sine function? Turns up in this calculation, turns up in that calculation. It's being used all over the world right now. I would say that PowerPoint is a mathematical object, like one of those functions. And you would have to decide what you think about even just numbers in general, and then extrapolate from that to what you thought about PowerPoint.
You're right. You're totally right. I'm doing something here. I'm trying to wrap my head around how I think about computers and any complex system. It's not just a computer, any complex system that we think we understand, and say, what light does that shed for me on thinking about the brain and behavior that comes out of the brain? But you're right that mathematics is relevant in thinking about mathematical functions. And honestly, again, my tendency, without having thought about this deeply and educated myself about this deeply, I'm of the camp that says mathematics is out there waiting to be discovered. It's not an invention of humans. It's out there waiting to be discovered. And if they're, one of those exoplanets that Jennifer Weisman was talking about yesterday afternoon, if there's a race out there, a different civilization, a different race of beings that's achieved intelligence and can actually communicate back and forth with us, they would have to have independently discovered sine functions. that's the nature of reality, I think. This is the unreasonableness, unreasonable effectiveness of mathematics.
It probably wouldn't have PowerPoint. Exactly.
Hopefully they have something a lot
That'd be
better.
way ahead of
Horrible.
PowerPoint. Much better programs. Yes,
Horrible
please. Yes.
presentation.
Yeah.
To me, that does have the echo of Platonic ideals to it, the way that you're talking about math there, yeah. Which brings back my question before, and I'm interested in your comment on it, the idea that that there's some degree of Platonic dualism in the way that we're trying to understand the monistic view of the person.
Okay, so this was a thought in my head when you asked that question previously. I think it was you. Maybe it was someone different. But my immediate rejoinder to that, in this little echo chamber inside my head, was no. We're not talking dualism here. At least not when we're talking about PowerPoint. We're not talking dualism because PowerPoint has to be instantiated in a some kind of physical instantiation. It has to be on a computer, it has to be written down, it has to be stored on a disk. Somehow it has to be there. I don't believe that PowerPoint exists. I really do believe PowerPoint is a human invention, and I don't believe it exists outside of any particular instantiation.
Could I say that? There's two things in Plato that I think are getting confused here. One is his mind-body dualism, and the other is the forms versus particular things. There's a connection between those two oppositions, but they're two different oppositions.
Maybe Descartesian ones.
Yes, Descartes and Plato are very close on the relation between the mind and the body. But you are talking, when you're talking about PowerPoint and things like that, that's more like what Plato has to say about the forms. And you are coming down with Aristotle against Plato. That is, that the forms exist only in their immaterial embodiments.
I'm glad to learn that. I need to learn more about that. Am I with Aristotle or am I with Plato?
I mean, it's often said, isn't it? It's all been said before, either by Aristotle or by Plato. And it's sort of it's interesting, isn't it? How? Yes, please. Yeah, keep it brief. Thank you. Yes.
I'm beginning to see what the huge problem is between scientists and theologians, and I think it's typified by the man by the pool of Bethesda, in the sense that there is not, within theology, there is this element of things don't need a rationale, in that the man by the pool of Bethesda, when Jesus comes up to him and says, "Do you want to be whole?" he says, "Well, I've got no one to take me into the water." He's looking for a rationale. And Jesus says, "Get up and walk." And to my sense of things, that's the whole difference between physics and metaphysics, is that in spirituality, you're dealing with love and serenity, which actually don't need a rationale. Whereas in physics, you're always looking for reasons. In fact, you're trying to control your environment. Whereas I'm working as a church minister, I know that God already does it, and that's what the huge gulf is between the two disciplines, and I can understand why we're going to have more interesting conversations.
So, I take your point, and I believe that God is behind this universe, and that God created through an evolutionary process, and that what we learn about the mechanisms operating in the brain are things that grew in God's universe. I believe that God intends loving relations for us to, that's the greatest embodiment for us to be together as a community. So I'm right with you on all those points, a certain amount of serenity that I only manage to achieve in rare circumstances. I'm right with you that that's in some sense intended. Maybe where we differ is that as a neuroscientist, I would say that, the love, the motivation to love, the serenity that one feels when in right relationship to God, that those things have physical instantiations in the brain, that those states of being and those states of mind, if you go from a state of unserenity to serenity, things will be changing in your brain that are correlated with that. So I don't think I have any deep conflict with you on the origins of love and serenity.
But do you think within the site of the brain, you've got the phenomenon of Mozart, who is literally writing down music? I don't think the human brain has the capacity to come up with the sort of things that Mozart was writing. And people who write about Mozart said, that he wrote it down without any mistakes. And to me, that is the whole problem between physics and metaphysics. You're trying to contain the faculty of consciousness within a human brain, and the consciousness is God. I mean, that's the theological standpoint. And it's pointless trying to say, well, it's driven by the human brain. You would like it to be so you can control it, but theologically speaking, metaphysically speaking, I don't think you can go there.
So just Dennis, one quick thing. You uttered the C word, that's the consciousness word, and you'll notice that other than that one slide here, I didn't say anything about consciousness at all. I mean, I think this free will thing is, and the self-determination, autonomy thing is something potentially we can wrap our heads around and come to understand neurobiologically. This consciousness thing, I don't know at all. I think it's one of the two miraculous things about nature, seemingly miraculous. One being, the physics question, the fact that there's something here rather than nothing. How do you explain that? And then how do bits of matter inside my cranium become conscious? I don't have a clue. And despite all the books you'll find at Cambridge University Press bookstore downtown, or at the Standard bookstore, I don't think neuroscientists have any clue how matter becomes conscious. I don't think modern scientific theories are up to that. I really do believe in Chalmers' hard problem of consciousness that Peter talked about. It is a mystery to me.
Wait, even a book called Consciousness Explained
Yeah.
by that well-known philosopher.
Yes.
We won't mention. Ian,
Yeah.
question, yeah.
Well, thanks, Bill. You offered us what seemed like 4 options or ways to explain free will, and you ruled out 3, and you plumped for self-determination or autonomy.
Yeah.
And I wanted to ask whether you thought that actually self-determination or autonomy is in fact inconsistent, for example, with bottom-up determinism. I mean, because it seems to me one could adopt a bottom-up deterministic viewpoint, which you say many of your colleagues do, and still say, that in a certain sense the brain is autonomous. I mean, because nothing outside of me is constraining the results of my cogitation or of my action. So it didn't seem to me completely obvious that a bottom-up deterministic view of how the brain works, which is not actually what I think happened, but it's not obvious to me that that's inconsistent with a definition of free will in terms of self-determination and autonomy. What do you think about that?
Okay, so I want to distinguish. First of all, I'm a reductionist scientist. All of my life, my 35 years in this business, I've been doing reductionist science. I've studied vision, trying to understand how electrical activity in the brain enables us to see. So I'm a reductionist scientist, and I think the distinction I want to make is between reductionism generally in terms of discovering mechanisms versus the eliminative reduction, the fundamentalist reduction. So that's what I'm really railing against or plumping against, as you would say. Do you plump against things, or do you only plump for things?
Plump 4 things.
You plump for things, okay. So if by reduction we mean that we believe that if we get to some fundamental level, that's where ground truth is, and that's where the most deepest understanding and best prediction lies, and we can throw away all of that overlying stuff. If that's what we mean by reduction, then yes, I'm against it, and I don't think that starting at that fundamental level and trying to build back up will yield you anything like an autonomous brain, because I don't think quantum mechanics in its poverty can even tell you about brains, and I don't think it can tell you about people, much less anything that a brain does. The quantum mechanics is just
maybe
just
I
collection
noticed
to that.
wrong, but perhaps the distinction is between reductionism and determinism. Okay, and perhaps an important distinction needs to be maintained between those two.
Okay, yeah, I mean, to me they're linked a bit. I mean, you can do reductionism without strict determinism, right? Because quantum mechanics is not deterministic, right? So, and there are ways in which that affects our behavior. So the absorption of photons inside the photoreceptors in the eye is a quantum mechanical event. The absorption of high energy radioactive particles from the sun in my skin is a quantum mechanical event, and it can cause melanoma and radically alter the course of macroscopic life for me. So I don't believe, I guess, if I were a complete eliminative reductionist, I would still not be a determinist in some sense, that fundamentally unpredictable events can wildly alter the course of events here. So is that to be continued?
I think we've got time for one more question. Rodney. Yes,
Yeah, well, it's simple.
yes.
It's are you then a libertarian in terms of free will rather than a compatibilist?
So I, not being deeply schooled in philosophy, and I need to learn more, I don't think of those terms. I'm just trying to figure out how the thing works and how behavior is related to the nervous system. I think, having listened to some discussion and read a few things, I'm trying to be a compatibilist. That's what I think. I think that I'm trying to be a compatibilist in the sense that what we most mean by freedom, this self-determination and autonomy thing, where our beliefs are real causes and our volitions and our aspirations are real causes. They're not just fluff. They're real causes that shape behavior. And I'm trying to say that there are ways we can study the nervous system that map onto that well. If we talk about these different levels of organization, if we talk about mutual manipulability, the fact that we can manipulate the high level, we can copy and we can alter the course of events, that's a knob that we can turn. And if that's a belief, and we can, Aaron Beck can make people's lives better by turning knobs at the level of beliefs. I mean, that's causation to me.
But it's still deterministic then, you're saying, so...
Yes,
in that case.
In that case, right. Now, so deterministic in the sense that that output has causes. And I want to say that our beliefs, our memories, our volitions are first-class causes, But determinism, so let's think about determinism. I've given Ian one example where determinism fails, right, in skin cancer and seeing dim lights. There are other ways in which determinism fails. So much of our behavior, you can put people in situations where decisions appear stochastic. Firing of action potentials appears stochastic. You put somebody in a moral dilemma and you're right on the knife edge. I don't know, it seems good this way and good this way, and it also seems bad this way and it seems bad way. You're right on the knife edge. And stochastic thermal noise can tilt you in any one given situation toward that one or that one, right? But the interesting thing is that even though that decision may be stochastic and therefore not deterministic in a strict sense, physicists don't like that because even thermal noise is determined. Is that what you're thinking?
No, well, I'm thinking that still wouldn't be give you libertarian free will.
No, I don't think I'm looking for libertarian free will. I'm looking for a definition of free will that is honest and tries to name what we really think about it and get away from the easy illusion of freedom and uncaused, but try to think about what causes really count and where do those reside in the nervous system and how does that relate to biology and physics. So I guess I'm not libertarian in that sense. I mean, libertarianism, as I understand it, just says that we are free, our decisions make a difference, and that is totally incompatible with a mechanistic view of the brain and behavior. Is that a capsule summary of libertarianism?
I think by supper time, by dinner this evening, we are going to know from the philosophers what the answer is. And we look forward to that. We're going to carry on this discussion. Well, let's thank Bill very much for a great talk.